Assalamualaikum warahmatullahi wabarakatuh. My name is Amir Rafiq Bin Rizal, and for today I will be presenting about Module 3554, which is about Spatial and Geostatistical Analysis. The objectives for Module 3 is to learn the technique to buffer and overlay from spatial data. Second, to understand the function of spatial analysis. Third, to understand how to merge two or more feature classes, vector files or raster files into one single feature class or raster dataset. Fourth, to understand fundamental GIS using ArcGIS. Fifth, to familiarize component in ArcGIS. And last but not least is to recognize geospatial data. And now, let's go to the methods. And now, let's start for our methods for Module 3, Spatial and Geostatistical Analysis. For the spatial analysis, the first step is buffering in ArcMap. Create a new ArcMap project and add the derived SHP data layer and drag it to the table of contents. After that, left-click on the red arc toolbox to activate the Tools menu. Then click the Analysis Tools and click Proximity and click Buffer. The display window allows us to create a buffer layer. Set the input layer to derived SHP. Specify the output features, location and name. Enter the linear unit as 300 and set the units to meters. Set the dissolve type to all and then click OK. When the buffering process is finished, it should display the buffer data layer. Then, we will redo this buffer, but this time, leave the default dissolve type to 9. The second step is overlay in ArcMap. First, open Arc Toolbox and then click Analysis Tools and then click Overlay and then click Erase. Specify input features as a derived buffer 300. Specify the erase features as a derived SHP. Set the output destination in the output feature class and then click OK to apply the buffer. Once you've erased the leaks from the leaks buffer layer, the final step is to overlay the two buffer layers. Select Arc Toolbox and then click Analysis Tools and then click Overlay and then click Union. Then specify the input layers, District Kelantan SHP and derived buffer 300 SHP. Then specify the output layer, derived district union, and then press OK. Examine the union layer and open attribute table for this layer. Select the polygons that meet both the within the roads buffer and the within the lakes buffer criteria. Next, to determine the site experience highest water reservoir and retention, overlay the derived SHP, District Kelantan SHP. Double-click on Intersect tool in Analysis tool. Select derived SHP, District Kelantan SHP for the input features and enter final SHP for the output feature class. And that is all for spatial analysis. And now, we will start with our geostatistical analysis. From the ARC catalog, drag Daerah SHP to Table of Content. Then click Arc Toolbox, click Convention Tools, and click Excel to Table to import Excel data format into ArcMap. it will be like this. Then right click at data ground at table of contents to display the data into point. Choose the X and Y based on the coordinate of the data. For the X field, choose E. For the Y field, choose N. Then click OK. Right click at the point of data to export the data to shapefile format. Then save the data at the project folder. The name will be changed to 1 July 2015 and then click Save. At the layers, the data ground will change the name. Next, we can start with our geostatistical analysis. Click Customize and then click Toolbars and click the Geostatistical Analyst. The Geostatistical Analyst toolbar is added to your ArcMap. Then create an interpolation a surface of PM10 using the default Geostatistical Analyst. Click the Geostatistical Analyst and click Geostatistical Wizard. Then click Inverse Distance Weighting in the Method List box. Click the data field arrow and click the PM10 attribute. Click Next to the method properties and click Finish at Cross Validation. It will be like this. Right click at Layers in Data Frame in the table of content and then click Properties. After that, click the Data Frame tab. For the Specify accent, the layers must be in Daerah. For the Click to Shape, the layer also needs to be in Daerah. After that, click OK. Then, right-click at IDW layer and click Properties. Then click Extend. Set the extent to the rectangular extent of Daerah. And then click OK. Then it will be like this. After obtaining this, drag 1 July 2015 until the top to make the points. And that is all for the methods in Module 3. Thank you. And now, let's start for the practical practices for spatial analysis. The first one, discuss how do the results differ between dissolve all and dissolve none in buffering, and when would this be important. So first of all, what is buffering? So buffering is an important tool for determining the area covered with a specific location, and optional dissolve can be performed to rename overlapping buffers. So what is dissolve all and what is dissolve none? So dissolve all are all buffers are dissolved together into a single feature by removing any overlap. It can measure the distance between two-dimensional Cartesian plane. It has also a simple feature output. Next is dissolve none. So an individual buffer for each feature is maintained because of overlap and known as default. It is separate and has individual shapefiles. It also has detailed graphic output, more detailed than dissolve all. Next is screen capture each overlay analysis done and explain the overlay features. So the overlay analysis that we did is erase, union, and intersect. So erase. It creates a feature class by overlaying the input features with the erase features. It will clear out the selected portion and a new shape class will be shown. An example, removing river features from a map. Next is union. Union computes a geometric union of the input features. Combine every overlapping features and make it as one. when combining state area, all of those states can be seen in the map. However, it can still be differentiated one by one. Next is the intersect. Intersect computes a geometric intersection of the input features. The output feature class will be written by using overlap feature in all layer of feature classes. And now the third one. How is the XY tolerance defined in the intersect dialog? And how many records does final SHP have? So, XY refers to the minimum distance between coordinates before they are considered equal. It is also calculated as a function of the projection definition assigned to the feature class. And the records for final SHP was 343 records. And last for spatial analysis is highlight all spatial analysis performed in this practical and relates the function of each analysis with real application in environmental context. So the two things that we did for spatial analysis was buffering and overlay. So we all know buffering is an important tool. It creates a buffer zone that is an area within a specific distance. It has the purpose of protecting environment, residential areas, commercial zones from accidents or natural disasters. So how do we take this buffering into the environmental context? So as you can see, there's an article written by Ahmad Chebon in 2021. So this article talks about a case study that was done by Chedon Ahmad. He talks about how the biodiversity is declining in sustainability, livelihood, and human well-being. So these buffer zones that was obtained by buffer can help conservation these areas to be intact. So these buffers can help the biodiversity. And next is overlay. So overlay, a method for determining the relationship between two polygon features that shares a common region. As we all know before this, the three things in overlay is erase, union, and intersect. So as you can see, this article, mapping risk areas of tuberculosis using knowledge-driven GIS model in Shah Alam, Malaysia 2017. Even though it says 2017, this idea started in 2015 when WHO stated that Malaysia has the worst cases of tuberculosis. So therefore, overlay comes in handy. And so having this type of overlays, we can see the location that is really concentrated with factories that can harm the air pollution. If you don't know, tuberculosis one of the factors is air pollution, especially ambient air pollution. So factories can release these gases, thus making some people have tuberculosis. For the geostatistical analysis, we only have two things. You have tried several types of interpolation method. Screen capture the output and explain based on your observation the difference between all methods. So the two methods are IDW and Kriging. So IDW is inverse distance weighing, IDW. It is a deterministic method. IDW uses interpolation method that shows the correlation of distance and weight towards the spatial data. Unknown value was estimated based on the neighboring values. Weight increases as the distance from measured points closer to predict points. It cannot estimate above maximum or below minimum values. Next is Kriging, an advanced geostatistical method. Kriging uses interpolation method that shows the correlation of distance, direction, and statistical data towards the spatial data. Unknown value was estimated based on the average points. The localized pattern were produced by the sample points that define the way. And last is summarize the use of geostatistical analysis used in this practical in environmental study. As we all know, the geostatistical analysis was the Kriging. So geostatistical analysis are used in the Kriging method. Kriging techniques can be used to describe and model Spatial patterns predict values at unmeasured locations and assess the uncertainty associated with a predicted value at the unmeasured locations. Study of landslide in 2012 uses cruising to calculate the factor of safety and failure probabilities for the area of Kota Kinabalu, Sabah. It can also be used to estimate pollutant levels in order to determine whether they pose a risk to the environment or human health, and if so, whether remediation is necessary. And that is all for Module 3. Thank you.